Hello friends, in this video we will talk about a concept which is known as escape velocity, and it is sometimes also known as escape speed. Okay, so as the name suggests, escape velocity means a speed or velocity required to escape the influence of some other object. In this case, we will be calculating the escape velocity for a planet. Then we will calculate the escape velocity for our Earth and its satellite, the Moon. Okay, so this will be the sequence of this video. So let's begin. So first of all, let us quickly recall the concept called gravitational potential energy. Okay, so let us assume there are two objects. Let us say a bigger object of mass m and another smaller object of mass small m, and the distance between their center of masses is r. Okay, so the gravitational potential energy of these two masses is given by U equals minus G m upon r plus a constant. Okay, this constant is arbitrary, and we all know that the gravitational potential energy has its meaning only when it is compared to the gravitational potential energy at another point. That is, only the difference of gravitational potential energy is what really matters. Therefore, we can choose this constant to be equal to 0. So what will be the formula become? U equals minus G m upon r. Okay. Now what will happen if the distance between their center of masses becomes very large? Let us say r tending to infinity. In this case, the potential energy U will tends to 0 because r is in the denominator. 1 by infinity is equal to 0. Or we can say the potential energy of a system at infinity is equal to 0. Okay, this is the concept which we'll be using in deriving the escape velocity for an object or a planet. Okay, so just remember this thing. Now let's proceed. Let us say there is a planet . Okay, this is the center of mass. Let us say this is the radius r, and this is having a mass capital M. And let us assume that this boundary or this line denotes the infinity line. That is, this line is at infinity from this planet. Okay, now let us assume there is an object lying on the surface of this planet. If we throw this object with some speed, what will happen? It will go further away and eventually it falls back to the surface of this planet. But does there exist a speed, let us say u, with which if this object is thrown, it will keep on going and going till the point it reaches infinity, and either it go further straight away from the planet, or it will just stay over here, but it will not return back to the surface of this planet. So the answer is yes, there exists such a speed, and this speed is known as escape speed, or sometimes escape velocity. Okay, so this is the concept of escape velocity. Now let us derive the equation for this escape velocity. Suppose this object, this is smallest object, is having a mass small m and is thrown with the initial speed u. So what will be the total energy, or I would say the total initial energy of this object? EI equals the kinetic energy plus potential energy, which is equal to half m u square plus what will be the potential energy? Minus G capital M small m upon R. Okay, this will be the initial energy. And let us assume this object reaches this or I would say reaches this infinity line with a final velocity equal to v. Okay, so what will be the final energy of this object? E final equals k final plus u final, which is equal to, the final speed is v, so kinetic energy is equal to half m v square. And what will be the potential energy? At infinity it will be simply 0, we have just seen it. So this will be the only energy which the object is having at infinity. Okay, so now according to the conservation of energy, the initial energy will be equal to the final energy. That means half m u square minus g m upon r is equal to half m v square. The masses will cancel out, small masses. So what we will get? We will get u square minus 2g m upon r is equal to v square. Now here comes the condition that v is the final velocity of the object and v can never be less than 0. That is, the only possible values for this right hand side, which is v square, is greater than equal to 0. That means the left hand side should also be greater than equal to 0. Or I should say u square minus 2g m upon r will be greater than equal to 0. This is the condition for the object to reach infinity or to just cross the infinity line. And what will be the minimum value of this right hand side? It will be equal to 0. That means the minimum initial speed required will be equal to u square minus 2g m upon r equal to 0. This is the condition for minimum initial speed to reach infinity or to escape the influence of gravitational pull of the planet. Rearranging this equation, we will get u square equals 2gm upon r, or u equals under root 2gm upon r. This is the value of escape speed for a given planet of mass m and radius r. Okay, now let us calculate the escape speed or escape velocity for Earth. Escape velocity or speed for Earth. So in the case of Earth, u equals under root 2g mass of Earth upon radius of Earth. Now we all know that the acceleration due to gravity at the surface of Earth is given by small g equals gme upon re square. Therefore, the escape velocity will become u equals under root 2g re. This is the value of escape speed or escape velocity for Earth. Okay, so let us calculate this value. We all know the acceleration due to gravity, small g, is nearly equal to 9.8 meter per second square. Radius of Earth is nearly equal to 6400 kilometer. So by putting these values in this formula, we will get the escape speed for Earth is equal to 11.2 kilometer per second. Okay, so this is the minimum value of speed which is required to be imparted on an object at the surface of Earth so that it will never returns back to the surface of Earth. Okay, so I hope this is clear. Now let us proceed further and calculate the escape speed for Moon. In the case of Moon, we have escape speed for Moon is equal to under root 2g mass of Moon upon radius of Moon. By putting the values of mass of Moon and radius of Moon, it comes out to be equal to nearly 2.3 kilometer per second. This is quite less than the value for our Earth, nearly 5 times. That means the escape velocity for Earth is equal to 5 times, nearly equal to 5 times the escape velocity for Moon. Okay. This value of escape speed for Moon is very less as compared to that of Earth, and this is the only reason why Moon has no atmosphere. Because whenever there are some molecules formed on the surface of the Moon having velocities greater than this 2.3 km per second, they will simply escape the gravitational pull of the Moon, and hence there is no atmosphere, because atmosphere is nothing but accumulation of many molecules, gas molecules. Okay, so this is the end of this video. I hope all the things are clear to you. Thanks for watching.